Hello everyone. I'm hoping that you guys are doing pretty well, and I'm also hoping that you guys watched videos that I posted recently. And in this video, I am going to just summarize or review Article 210, uh, which pertains to branch circuits. So I put up again objective again. This is simply a review, nothing new. I'm going to ask you guys a bunch of questions, place some questions up there, and we'll go from there. And very soon, I'm going to post a study guide for the exam number one, which is coming up a week from today. So hopefully, we will have some live sessions coming up shortly. Uh, I may review the entire exam online if we cannot see each other in person. But I would highly recommend, guys, that you read up Article 210 one more time and then write down the questions, make questions for me, ask me questions using your email addresses, cell phones, whatever is possible. The objective is to communicate with one another, not to just disappear and not to do anything. Yeah. So again, I put the objective up there. We'll be discussing again. This is code B, applies to code B. Brain circuits. As I said, this is just simply a review. Multi-wire brain circuits. Discuss a little bit about GFCIs, AFCIs, and replacements. Majority of your test, guys, is going to be from this article. My strictly guess is about 70%. So first of all, let's talk about the brain circuits. I think I asked you this question last time, the very first time when you guys started this class, and I have you in my class. What is a branch circuit? What is a branch circuit? So I'm pretty certain most of you guys know what it is, but this is any circuit that basically extends beyond the final overcurrent device. So again, I'm going to draw it one more time. So assuming that this is your final overcurrent protection device, OCPD, and of course we have breakers up here. As you guys know that when it comes to the listing, the odd numbers are listed on the left side, the even are on the right side. But again, the objective is what is a branch circuit? Or the question is, what is a branch circuit? Any circuit that extends beyond the last final overcurrent device. So in this case, I'm going to draw this one. This is our sub panel known as overcurrent protection device. So I'm going to place a couple of things here. So what we have here is, this is, I can have small appliance branch circuit. So when it comes to that, could be one of the small appliance branch circuits. Okay. So I'll a bunch of examples up here. So small appliance branch circuits. So what is small appliance? Again, as everybody knows that in your kitchen, you have a bunch of receptacles on the countertops, and then you do plug devices in, toasters, ovens, small microwaves, juicers, coffee makers, blenders. The list goes on and on. But those receptacles are 20 amp receptacles. They are basically controlled by your panel, your breaker over there. So if you open up your service panel, you're going to see two branch circuits or two circuit breakers in your panel says kitchen one, kitchen two. As you guys know, the minimum requirement. So what is the minimum requirement for small appliance branch circuit? So what is the minimum requirement for small appliance branch circuit? The minimum requirement is two. So that means you need two of them. So small appliance, again, I don't need to write anything, everybody knows what it is. So this is one of them. The next part, you can have, now this is one example, the branch circuit. The next one is the garage. You have outlined the garage. So we can have garage outlet. So that's branching off of this one. Then we can use bathrooms here. That's another one of the branch circuit. Then we have general purpose receptacles, outlets. They are our branch circuits. Okay. So these are just some of those examples that you may know that anything that extends beyond the last overcurrent device. Okay? That's basically called a branch circuit. And we need to have the power. Again, so we get a bunch of circuit breakers that are going to drive this. And of course, then we have the conductor in between. So you have, these are the branch circuit conductors. And very soon, hopefully in my next video, we're going to go back and try to size this one up too. So, but these are the conductors that are going to provide juice and current to these branch circuits. The next one is, of course, multi-wire branch circuit. So what is a multi-wire branch circuit? Again, it is based some of the requirements that when it comes to multi-wire branch circuit, you have two or more ungrounded conductors that share a neutral. And then the multi-wire branch circuit must originate from the same panel board, which is basically, in this case, this is our panel board or our breaker. So these branch circuits that are going to share resources from this part, they must originate from the same panel. They must have same one disconnecting means. That means if something happens to the neutral, both ungrounded conductors, which are hot wires, they are going to be disconnected. Okay? They must provide line to neutral loads. They must be grouped together. So these are some of the requirements when it comes to multi-wire branch circuits. Now again, when it comes to going back to all of these small appliance branch circuits, we need to protect these devices from dangers of using electricity. We need to protect personnel that are basically using them. So what we do in this case, we have a device known as GFCI. Okay. I'm pretty sure everybody knows what GFCI stands for. I did ask one of the questions during the lecture session that what is ground fault? So what is ground fault? Okay. Some of you may already know what it is. Some of you may have forgotten that because I'm pretty sure you learned this on previous course as well. But the ground fault is when your ungrounded conductor, which is basically a hot wire, makes the contact with either metal box or comes into contact with your ground conductor. And that's where GFCI basically pops open. Now, there are certain reasons that can basically break the GFCI open. One is, of course, ground fault. The other one is a short circuit. That means you have two hot wires, they can touch each other. Hot neutral can come into contact. Faulty equipment can cause problem for GFCI to actually break open. And then overloading. So you apply press too many. But again, when it comes to the protection, overcurrent protection, GFCI is not an overcorrection, current protection device. As you may know from the previous classes, that the difference in currents between line in and out, that is between anywhere between 4 to 6 milliamps, that basically pops it open. And then what GFCI does, it basically protects you and equipment. And then we have another one, AFCI, arc fault. that basically protects or prevents fires and indirectly protects you and me. Okay. And then when it comes to, okay, let me go back to the GFCI one more time. It is possible that we're going to ask you to list places where GFCIs are installed, and you all know where they are installed, but we will also ask you name places where GFCIs are not required. And then you guys know that there are a couple of places that GFCIs are not required. Uh, well, more than a couple, so your hallways and your bedrooms, family rooms, living areas, they don't require GFCI. But on the other hand, we have an AFCI, which is required almost everywhere except three things. Can you name? I'm going to ask you a question. Please answer me through email or through my email. So list. This is for you guys out there. List three places where AFCI is not required. Okay? So again, you are going to answer that question through email. So for this one, you can post your comments on through the Google Classroom. So please work on that one. And then the last one again, receptacle we just finished in previous videos. So you have general purpose receptacles that are required within 6 feet of your entrance when you walk in from the door, within 6 feet and 12 feet thereafter. With one exception that as long as the wall space is 24 inches long. Now, how do we define wall space? Any space that is minimum of 24 inches long, unbroken space, no barriers, no sliders, no moving parts, fixed. And then we have countertop receptacles, again, something 2-4 foot rule. So you need a receptacle within 2 feet from the end of the countertop and then 4 feet thereafter, provided the wall space is 12 inches long. That's another requirement that you have to keep in mind. And if there is any barrier in between, if there's a break, there's no usable space, that means any place where we cannot place the receptacles, that's no. So you start fresh from the other side and count 24 inches, 2 feet, and then go all the way. Outdoors, you need minimum of 2 receptacles, front and back. And then when it comes to garages, each carport needs 1 receptacle. And then hallways, you are required to have 1 as long as the hallway is minimum of 10 feet long. Okay. So from there on, I'm going to post, write down, ask you guys a few more questions, and I need a response back from you as soon as possible. Again, I would highly recommend that you read Article 210 all the way from top to the end. I have also listed reading assignments for you guys on online, or posted them online or through Google Classroom. So please take a look at them. And if you have any questions, again, this system is completely new, so we are learning as we go. And then if you have questions, please post your comments about anything. Let me know how I can improve. Again, this is first time I'm videotaping all of my lectures. I don't see any students here, so it's a little bit strange situation, but we'll get through. I'm hoping everyone out there is doing well, staying out of trouble, and I'm hoping I'll see you soon. So please read up all of these, and then have a good day.